Hello, everyone. My name is Grzegorz Jurdziński. I'm a machine learning engineer at deepsense.ai, and today I'll talk about LLMs deployment, in particular about Hugging Face Text Generation Inference and the alternatives. The talk is based on my recent experience with this tool. In the previous project I worked on, we did deploy LLM, and we investigated a couple of options. We eventually went with Hugging Face TGI, so I'll mostly cover that. Quick side note, all the recommendations, pros, cons, and so on are given for now. The branch is developing rapidly, so the situation might be completely different in just a few months. So I'll start with a brief introduction to the topic. I'll talk about what challenges do LLM deployment pose, what we should consider when doing that task. Then I'll briefly cover tools from cloud providers. After that, I'll talk about manual deployment. And then I'll move on to the main topic today, Hugging Face TGI. After that, I'll compare it to a couple of alternatives. And we'll summarize all that, what we've learned today. So what all the fuss is about? So I think I don't need to convince you that LLMs can be useful and are very popular. The thing is that they are very large and complex models, and the branch of LLMs is rapidly developing. So all of that makes LLM deployment not a trivial task. And the main issue, like the core issue, is very simple. LLMs are large. So that causes that we need a proper hardware to run them, which might end up with high costs. And being large, to get a prediction from LLM, we need to do a lot of computation, and this results in high latency. So high costs and high latency are the key reasons why we want to deploy LLMs mindfully to minimize this cost and latency. So a couple of things to consider are, of course, model choice. Size, performance might vary. There are different licenses as well, so not all models are available commercially. We should also consider latency versus throughput, so there is some trade-off between these two metrics. So when deploying LLMs, we should think what's more important for us and how much we can trade off one for another. And what we'll focus on mostly today are the deployment options. So of course, we can deploy either on cloud or on our own hardware. And we can choose from many different tools, frameworks, and so on. Of course, there are many other things we should consider. So let's move on first to the tools that we get from cloud providers. What I mean here, stuff like Vertex AI from GCP, SageMaker or Bedrock from AWS, or ML Studio from Azure. So these kind of tools have a couple of nice upsides. So first of all, they are more or less ready to use out of the box. Often it's just few clicks we need to do here and there. There is really minimum setup needed to get them running. We don't need to define and manage the infrastructure, or it is limited to minimum again. And of course, they are not free, but available for commercial use. But this comes with a couple of downsides. So the largest, or one of the largest in my opinion, is that it binds you to one cloud provider. And as an example, I'll mention this project I worked on. So during this project, we knew that we'll be working with GCP, and we won't move to any other cloud provider, but we still benefited from not using Vertex AI, because at some point during the development, there was a problem with GPU's availability on GCP. And because we had another deployment prepared, we could easily, for the development time, move to our own infrastructure, to our own machines, and we didn't need to stop the development because of GCP's problems. Of course, other cons are limited flexibility. So there are some options available and nothing else. And these tools are not open source, so we don't really know what's going on under the hood. The alternative is what I decided to call manual deployment, and this includes both on-premise and on-cloud. What I mean by manual deployment here is preparing your own implementation or using some ready service and deploying it using Docker, Kubernetes, or any other similar tool, and deploying it either, as I mentioned, on-premise or on cloud. In this situation, we would usually use some tools designed for LLM deployment, and some we'll talk about today are Hugging Face Text Generation Inference, our main hero today, but there are also alternatives like VLLM, C-Translate from OpenNMT, or machine learning compilation, or MLC for shorter. So contrary to the cloud providers, these are easy to migrate to another infrastructure, either another cloud provider or our own machines. They often provide you with larger choice of features. They give you more flexibility. Many of these options, most of these options are available for commercial use. And important upside is also that they are open source, so we know what's going under the hood. It's easier to debug some stuff. But of course, they come with some cons. So there is more manual work needed to make them working. Although later I will try to convince you that at least in some cases, there is still very little work needed to get them running. Some of these tools have limited commercial use, and as we experienced during our project, they have diverse quality. So some of these tools are not that major and might cause some issues. So let's move on to our main character today. Hugging Face Text Generation Inference, or TGI for shorter, is fully functional LLM as a service. And it's optimized for many popular models, including but not limited to Llama 2, Falcon, or Mistral. It is possible to make it work with other models as well, the ones it is not optimized for. Contrary to some reports, it is fast, and I'll talk about it more later, and stable. I'll show in a second that it's very easy to use. Important thing for me when I was working with it was that it's well maintained. It has a large community and is constantly improved. So there are forums. The authors are responsive. So it's you're not left alone with it. It is open source, but license forbids some commercial use. So now I'm not a lawyer, so don't take my words for granted. By my understanding of a license is that offering TGI as a service itself is commercially is forbidden. So you can't, your product can't be that you just allow your users to run LLMs on your machine with TGI. But in our case, the LLM was just a part of a larger product we built for a client, and was perfectly fine to use it. So I mentioned that it's very easy to use TGI. So here is a proof. Say we want to deploy a Falcon 7B instruct model. So we'll use the copy from Hugging Face Hub. Quick side note here, it is TGI is released by Hugging Face, but no knowledge of Hugging Face itself, Transformers library, is needed. It is helpful where if you need to dig into the code, but as a user, you don't need to know it. So we define the model we want to use. We'll need a volume to store the weights, and all there is left to do is just a simple Docker run command. The most important thing here is that. So we define what image we want to use, and that's publicly available TGI image. We specify what model we use, just a few other simple comments, flags, and we can send the request. Our model is running, is available for us after the startup, of course. What I showed here runs the model on our local machine. You might be interested how to do it in some other instances, but we run everything with Docker. So in our project, we ran it on GKE, which is Google Kubernetes engine, and it was just, in our case, 3, but I think you can make it work with 2 simple Kubernetes YAML file, so basic knowledge of Kubernetes is enough to get it running. So I'll briefly talk about how TGI looks under the hood. So it's split into two main components. On the right-hand side, we see the LLM deployment itself, and you see several model shards. So I'll talk a bit more about sharding or running it on several GPUs later, but basically this represents that we can run it on several GPUs. And we are provided with a web server on the left-hand side. The web server is implemented in Rust, but don't worry, I personally never wrote a single line in Rust, and I was perfectly fine using it. So having this web server gives you a really nice and usable interface with a couple of optimizations. So TGI includes many features, and some most important, in my opinion, include tensor parallelism. So tensor parallelism is a technique to run a model on several GPUs. The idea is that when we multiply we multiply two tensors, we can split one tensor into columns, spread it over several GPUs, and then just combine the results of separate multiplications. So this technique is faster than model parallelism. Model parallelism is when you do some layers computations on one GPU, then other layers on another. So this parallelizes better. And in our case, in our project, this was completely needed feature. We wanted to run Llama 17B, and the largest GPUs we had available were already very large, A180 gigabytes GPUs. And thanks to tensor parallelism, we could run it on two of these without much loss to the efficiency. It wouldn't fit on one, so that was something we literally needed. Other nice feature is quantization. So this, again, a technique to reduce memory and latency at the cost of performance, but it's still very, very useful. The simplified idea is that you represent model with, for example, 8-bit integers instead of 16-bit floats. And TGI supports quantization with bits and bytes library, which works out of the box. So all you need to do is, like, grayed out is the command I showed you earlier. You just add this red bit and you get it quantized. Other option is GPTQ. This one requires weights calibration. So you can, for that, either use a TGI provided tool for weights calibration, or on Hugging Face Hub, there are many popular models already calibrated for GPTQ available. So in such case, you would only need to change the model and mention that you want to quantize it with GPTQ. The newest release also allows you to use AWQ and EEDQ. There are two other techniques for quantization, but I personally didn't try it yet. And again, this was a very, very important feature to have in our project. So during the development phase, we wanted initially to work with a smaller model, Llama 27B, and normally it wouldn't fit into single Tesla T4. But thanks to quantization, for the development purposes, we could deploy the quantized version on single Tesla T4. So thanks to that, we had smaller development costs, and also it should work fast as well. Another available feature that we actually didn't use because it didn't match our needs, but in many cases is useful, is token streaming. So again, this allows retrieving answer tokens, token by token, instead of waiting for full text. And these graphic from Hugging Face, in my opinion, visualize it pretty nicely. So you can start reading the answer already while the rest of it is still being generated, instead of waiting for all of it. So for example, if you have a system that produces 100 tokens per second, which is much faster than any human can read, user would need to wait 10 seconds to get 1,000 tokens. But if you use token streaming, they can already start reading. There are also other features, very, very nice to have, but I don't have time to get into all of the details. But just to summarize, TGI is production ready, so it has distributed tracing with OpenTelemetry and Prometheus metrics available. The supported models have flash attention and page attention implemented as well. So these are techniques that allow you to lower the latency. It also implements continuous batching on incoming requests. So when I showed the diagram of architecture, there was a piece called batcher. So if there are many requests waiting in the queue to be processed, this batcher puts them into one batch and then sends a whole batch to the LLM. So this increases the throughput. You can turn on watermarking so that your answers can be distinguishable from human answers. So that's something that you might want to have in your project. And there are many other features that we don't have time to provide to cover today. So there are, of course, alternatives to TGI. And I already mentioned VLLM, cTranslate2, and MLC. They all, according to some reports, have better latency than TGI. I'll give you more numbers on the next slide. What's interesting about VLM is that it's under the hood, parts of it are used by TGI. We experimented with cTranslate2 as well, and it was a no-go for us, unfortunately, because it doesn't support tensor parallelism. So I mentioned that we wanted to deploy Llama 70B, pretty large model, and we wouldn't be able to do it with cTranslate2. MLC is a tool that is reported to be quite fast. We didn't manage to try it out, but according to my research, MLC focuses on deployment on edge. So for example, smartphones or personal computers. So if this is your use case, it might be worth looking into. cTranslate2 and MLC support a bit fewer models than TGI as well. So I talked a bit about the latency as well. And what we see here are numbers I took from a blog post that was our motivation to try out other options than TGI. On the y-axis, we see average tokens per second. So the more tokens per second, the faster the model is. And indeed, these blog post reports TGI to be very slow. For readability, I skipped MLC here, but it's supposed to be even faster than VLM and cTranslate, which are already over twice as fast as TGI. But we ran some experiments on our own as well with these three libraries. Quick side note here, we got much higher numbers with regard to tokens per second because we ran it on a better hardware. But what's most important is that the difference is not so big anymore. So according to our experiments, TGI is almost as fast as VLLM and it's only a bit slower than cTranslate2. And further research showed that there are some newer reports which confirm that TGI is just slightly slower, or some reports claim that VLM, for example, is faster than TGI only in some very specific cases, which are not that common. My guess is that the blog post I mentioned here was written around half a year ago, I think. And as I mentioned, this branch is rapidly developing. Since we started working with TGI, it had 2 or 3 new main releases, which improved actually the latency, or at least claimed to have improved it. So my best guess is that TGI is being improved, and over time it was improved. And now the latency difference is not that large. So far I talk only good things about TGI, but of course it does have some cons. The most important in my perspective is that it's not always working as smoothly as the authors claim. So especially when it comes to some of the optimizations, authors often claim that, oh, all you need to do is just turn on some flag, and you should have, for example, GPTQ working. And it wasn't the case for us. We had to adjust a little bit for infrastructure, or for hardware we ran it on. So sometimes it's tricky. Bits and bytes quantization is horribly slow. So I showed you that this is the easiest way to quantize the model with TGI. But at the same time, even though it is supposed to make it faster, it makes it much, much slower. Although it's worth noting that new release supports ETQ, which according to authors is a drop-in replacement for bits and bytes. Like, all you need to do is just change the quantized flag from bits and bytes to ETQ and should work. But I didn't get a chance to try it yet. Still, there are some tools faster available. I showed you that the difference is not that large, but our experience showed that other tools are faster indeed. Other downside is that while the core functionalities are well documented, and if you want to prepare some basic deployment, it will be very easy to do. Some of the extras are not really that well documented. So if you want to optimize your deployment, for example, I tried recently to dig into how the monitoring works. I couldn't really find good documentation. So that is not that well documented. And as I mentioned, it is not available for all commercial uses, but still this is small downside from my perspective, because only the vast majority of commercial use is still available. So to summarize, in my opinion, TGI is fast enough for production and easy to use enough for prototyping. So it's a win-win situation. I would consider alternatives if, first of all, one option, if I were committed to one cloud provider and I knew I would never need to deploy LLM or anything else, then I would consider using their solution. Other situation is that if I really needed to squeeze every millisecond of latency, then I would consider other tools. Although, as I mentioned earlier, these changes, so that would require a bit more research. So to summarize, would I use it again? Yes, given, of course, that it matches my use case. Given that the conditions hold in the future, I mentioned at the beginning that the branch of LLMs is developing rapidly. So I'm talking today on 3rd of January, and in a few months, say spring, summer, the situation might be completely different. And of course, there are some limited use cases forbidden by the license. So of course, it's as one needs to remember about that. So that's everything I had prepared for you. Thank you very much for your attention, and I'm happy to answer any questions you might have.